Question 10. Explain why it is not advisable to sterilize a clinical thermometer in boiling water at normal atmospheric pressure. Answer. A clinical thermometer has small temperature range. The glass will crack or burst due to excessive pressure created by expansion of mercury. B. State the effect of an increase in pressure on I, boiling point, and II, melting point of water. Answer. Increase in pressure. I increases the boiling point. II decreases the melting point. C. The diagram is on the screen. The graph shown above is that of the saturated vapor pressure SVP of water against temperature. Pure water is known to boil at 100 degrees centigrade and at an atmospheric pressure of 760. The graph shown above is that of the saturated vapor pressure SVP of water against temperature. Water is known to boil at 100 degrees centigrade and at atmospheric pressure of 760 millimeters of mercury. What general conclusion can be drawn from the information given above? Answer. At the boiling point of pure water, the SVP pressure of the water is equal to the external atmospheric pressure. A thread of mercury of length 20 cm is used to trap some air in the capillary tube with uniform cross-sectional area and closed at one end, with the tube vertical and the open end uppermost. The length of the trapped air column is 15 cm. Calculate the length of the air column when the tube is held. Calculate the length of the air column when the tube is held. I. Horizontally, II vertically with the open end underneath. Atmospheric pressure equals 76 cm mercury. Solutions. D. Diagram. You can see the diagram on the screen. Volume V is proportional to length L, stated or implied. I. P1V1 equals P2V2 implies P1 into 1 equals P2 into 2. In parentheses, 76 plus 20, 15 equals 76 times I. P1V1 equals P2V2 implies P1 L1 equals P2 L2. In parentheses, 76 plus 20 times 15 equals 76 times L2. L2 equals 96 times 15 all over 76. L2 equals 18.95 centimeters. II. P1 L1 equals P3 L3. In parentheses, 76 plus 20 times 15 equals 76 minus 20 times L3. L3 equals 96 times 15 all over 56. L3 equals 25. L3 equals 25.71 centimeters. Question 11. State two differences between a sound wave and a radio wave. Answer. A. Differences between a sound wave and a radio wave. Sound wave is a mechanical wave. Radio wave is an electromagnetic wave. Sound wave is longitudinal. Radio wave is transverse. Sound wave has speed less than speed of light. Radio wave has speed equal to that of light. Sound wave requires a material medium for propagation and cannot travel through vacuum. Radio wave does not require a material medium for propagation and can travel through vacuum. B. Explain why a vibrating turning fork sounds louder when its turn is pressed against the tabletop than when held in air. Answer. The vibrating turning fork forces the tabletop to vibrate. The tabletop has a much larger area and is therefore in contact with a larger volume of air undergoing vibration. Hence, sound heard is amplified. C. State 2 conditions necessary for the production of stationary wave in a medium, formation of interference wave patterns, occurrence of total internal reflection of wave. Answer. Conditions necessary for production of stationary wave are: 2 waves must be traveling in opposite directions. Incident and reflected waves must have the same frequency/wavelength. Incident and reflected waves must have equal amplitude. There must be superimposition. There must be a barrier. II. Formation of interference wave pattern. 2 sources must be involved. The 2 sources must be coherent/have a constant phase difference as well as the frequency and amplitude. The waves that are interfering must have the same amplitude. The distance between the sources must be of the order of the wavelengths of the waves. III. Total internal reflection. The wave must be traveling from a denser medium to a less dense medium. The angle of incidence of the wave in the denser medium must be greater than the critical angle for the medium. D. A ray of light is incident on one face of an equilateral glass prism. Draw a ray diagram to show the path of the ray through the prism. Draw a ray diagram to show the path of the ray through the prism. Calculate the refractive index of the glass if the angle of minimum deviation is 41 degrees. Answer. DI. You can see the diagram above. This is the correct diagram. II. N equals sine bracket A plus dm over 2 all over sine bracket A slash 2. Sine bracket 60 plus 41 over 2 equals sine 60 over 2, which equals 1.54. Question 12. State 2 essential differences between a moving coil galvanometer and a DC generator. Question 12. State 2 essential differences between a moving coil galvanometer and a DC generator. Answer. Differences between a DC generator and a moving coil galvanometer. DC generator converts mechanical energy to electrical energy. Moving coil galvanometer converts electrical energy to mechanical energy. A DC generator uses split rings or commutator. Moving coil galvanometer uses hair springs. DC generator rotation of coil is continuous. Moving coil galvanometer rotation of coil is incomplete. DC generator uses carbon brushes as terminals. Moving coil galvanometer uses jewel bearings as terminals. B. Explain the term eddy currents and state 2 devices in which the currents are applied. Answer. B. Eddy currents are currents induced in the conductor when subjected to varying magnetic field. Any valid additional information. Example. Eddy current flows in a circular path or closed loops. Eddy currents generate heat. Eddy currents cannot flow through gaps or slots. The currents move in such a direction as to oppose the change producing them. Devices in which eddy currents are applied. Pointers of sensitive electric meters. Sensitive mass balances. Brakes in large electric motors. Speedometers in automobiles. Detection of cracks in railway tracks. Detection of metals. C. State the principle on which the potentiometer is based when it is functioning. Answer. Principle on which a potentiometer is based. When a steady current is allowed to pass through a uniform wire, equal lengths of the wire will have equal potential differences. Or the PD across the length of a wire is directly proportional to the length, provided the wire has a uniform cross-section. D. A source of EMF 110 volts and frequency 60 Hz is connected to a resistor, an inductor and a capacitor in series. When the current in the capacitor is 2 ampere, the potential differences across the resistor is 80 volts, and that across the conductor is 40 volts. Draw the vector diagram of the potential differences across the inductor, the capacitor, and the resistor. Calculate the I. Potential difference across the capacitor, II. Capacitance of the capacitor, III. Inductance of the inductor, pi equals 3.14. Solutions. Vector diagram showing VL with arrow, VC with arrow, VR with arrow. V2 equals VR squared plus in bracket VL minus VC squared. 110 squared equals 80 squared plus in bracket 40 minus VC squared. 110 squared minus 80 squared equals in bracket 40 minus VC squared. In bracket 40 minus VC equals root 110 plus 80 into, in bracket 40 minus VC equals square root 110 plus 80 times 110 minus 80. 40 minus VC equals plus or minus 75.5. VC equals 40 plus or minus 75.5. VC equals 115.5 volts.